about this question, and I want us to work it out together. Okay, so it's coming from introductory physics. So we've got these vector components. The first one is this F180, the other one is F260, the other one is F350, and we've been given angles. And before I go anywhere, make sure that the angles that you are measuring, you are getting them from the positive x-axis, unless you know what you are doing. If you don't want to complicate things, angles, measure them from the positive x axis. You measure like that, or like that, or like that. That becomes easier for your work. All right. So we want to resolve this into components, then find the magnitude of these vectors, also the direction. Okay, so here's what we're going to do. So here I'm going to put the x component. I'll put x component here, then I'll put y component. All right, let's not forget that. So I'll put maybe in a table. Okay, I've put them in a table form. So remember that the x component is always given by what? That f, that force, or that vector, then cos theta. And the y component is given by that force, or that vector, then sin what? Sin theta. Now, it depends. If you use this if the angle is attached to the x-axis. You can also use f sin theta. Sorry, you can also use f sin theta for cos, for x-axis, if the angle is attached to the y-axis. I shall give an example. All right, so this is x. So here we'll say 80. So we are starting with the first one. Since this one is already attached to the positive x-axis, it's fine. Get the 30 the way it is. Okay, so cos 30, and I'm getting 69.28 newtons. Then for the y component, we'll do the same. For the y, so for the y, it will be 80 sin 30 degrees. Sin 30 just okay, there, yeah, 0.5. So this will be 40 newtons. So we're done with the first one. Then the second one, it will be 60 cos. Now for the 61, pay particular attention. We are getting the angle from there all the way to where it is ending. That's how we do it. Now remember that this is a straight line, and angles in a straight line add up to 180. So 180 minus 60 hapa, just pass 120. So the angle we are getting is 120, not 60. So 120 degrees. So what do we get? Compute with me, please. Compute with me. Compute with me. All right, so I'm getting cos 120 times 60. I'm getting negative 30. It's fine. Newtons. It will be very, 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 very fine. Okay. Then it will be 60 sin 120. So, and I'm getting 51.96 newtons. Let's go for the 50 cos. The angle, now we are going to move up to where the line is ending there. Now check, from there to here, it's 180. From there to there, it's 180. So we are saying 180 degrees plus. Now check, what angle is this? This is 30. Since I can 90, skis result is already known. So 30. 210. So use 210. So 210 degrees. Okay. This will be negative 43.30 newtons. Then here we come 50 sin 210. I'm getting negative 25.00 newtons. All right. So we've done everything. So let's add all the components in the x. We add all the components in the y. Then we'll be safe. So add this minus. Let's go. So I'm getting negative 4.02 newtons. Let's also add here. I'm getting 66.90 newtons. All right. Now resultant. It's time for the resultant. R or F, since those are forces. it will be root of the x component square and the y component squared. So I have negative 4.02, you square it, plus 6.96, you square it. Okay? Square everything, let's add. So I'm getting 4499.80. Our resultant force, or vector, whatever it is. So I'm getting 67.08 newtons. That's all. Now, the next thing, the first part is done. The next thing is direction. You should always know the direction of your vector. In fact, if I have to sketch this, which one? This component and that component, you will know that this is actually somewhere in which quadrant? Second quadrant. Because x is negative and y is positive. That is the second quadrant. It's like you have this, where y is positive in the second, but x is negative. So it's like you've got something like this, where, okay, then from there to there is 4.02, but a negative part. Then from there to there it is 66.96. This is the this is the f we are looking for, resultant. Use Pythagoras theorem, but we need the angle theta. That theta is the direction, but again from here you can just tell to say that the direction is between what? This is north and this is west. Is northwest, but let's do it the calculation properly. So direction, we use tan theta. You say just y, the resultant force in the y over the resultant force in the x. So the resultant force in the y was given that, and in the x was given that. So it will be 66.96 over, now just treat it as positive. I know there's negative there, but just take it as positive. It's fine. We will know why we are doing that. So meaning theta will be equal to tangent inverse of, so divide this into there, get the positive part, please. Okay, so 66.96 over 4.02. Let's find theta. Now, why we are finding this theta? This theta is just the reference angle. Remember, we have ignored the negative, but keeping in mind to say the angle lies in the second quadrant. And because it is tan is negative, where tan is also negative in the second quadrant. Okay, so this is just the reference angle. We ignored the sign. Take note of that, please. So let's go punch tan inverse, then divide this. I'm getting 86.56 degrees. This is just the reference angle. Can you find this angle in the second quadrant? No, you can't. So what do we do to find it? What do we do? So if we want to find theta in the second quadrant, we'll say 180 degrees minus the reference angle. So 180 minus 86.56. And now the actual theta should be 90 something. Yes, 93.44 degrees. That's all. Now, look at this number, this theta. Remember that all the angles were taken from the positive x-axis. So say this is 93.44 degrees from the positive x-axis. Done.